The universe has always been a place of awe and wonder, filled with mysteries that have fascinated scientists and stargazers alike for centuries. One of the most exciting developments in modern astronomy has been the advent of advanced telescopes, allowing us to peer deeper into the cosmos than ever before. However, a recent discovery by the James Webb Space Telescope, JWST, has sent ripples through the scientific community. The discovery of a galaxy, known as Sirius 2112, that resembles our very own Milky Way, and exists in the early universe, challenges many of the theories we had about the formation of galaxies. This is no ordinary galaxy, it is a barred spiral galaxy, the same type of galaxy that our Milky Way is, but it existed over 11.6 billion years ago, when the universe was still in its infancy. This revelation has left many astronomers scratching their heads, wondering how a galaxy so perfectly formed could have appeared so early in the history of the universe. In the early days of cosmology, researchers believed that the universe was an unpredictable and chaotic place. The first galaxies were thought to be irregular and disorganized, slowly evolving over billions of years into the more structured forms that we see today. Scientists expected that galaxies like our Milky Way, with their distinct spiral shapes and barred structures, would take much longer to form, perhaps billions of years more than what was originally predicted. However, the discovery of Sirius 2112 by the JWST suggests that these assumptions might be incorrect. The idea that such a galaxy, with a well-formed spiral structure, could have existed in the universe's infancy is nothing short of revolutionary. It opens the door to new questions and theories about how galaxies form, how quickly they evolve, and what this means for our understanding of the universe's history. To understand the significance of this discovery, it's important to look at how galaxies were expected to form according to the models that astronomers had been using for decades. According to conventional wisdom, the earliest galaxies were believed to have been chaotic and irregular, formed from the rapid cooling of matter shortly after the Big Bang. During the first few 100 million years after the Big Bang, the universe was still in a state of darkness, filled with clouds of gas and dust, as well as the first stars. These stars, known as population 3 stars, were thought to be massive and short-lived, composed almost entirely of hydrogen and helium, the first elements created after the Big Bang. It was expected that these stars would have lived fast and died young, exploding in supernovae that seeded the universe with heavier elements. Over time, these elements would form new generations of stars, which would eventually lead to the formation of galaxies. Galaxies were thought to be the result of the gradual accumulation of matter, with smaller clumps of gas and dust coming together under the influence of gravity. As these smaller clumps merged, they would eventually form larger structures, with the most massive galaxies forming from the collision and merging of multiple smaller galaxies. The process of galaxy formation, according to these models, was a slow one, taking billions of years. The formation of barred spiral galaxies, in particular, was believed to be a late-stage development, occurring only when a galaxy's central structure had settled into a stable configuration. The bar-shaped structure that is characteristic of many galaxies, including the Milky Way, was thought to form when stars in the inner part of the galaxy's disk were pulled by gravity into a central elongated shape. However, the discovery of Sirius 2112 challenges this view. The galaxy, which was observed by the JWST, shows a clear barred spiral structure, much like our own Milky Way, despite existing over 11 billion years ago, during a time when the universe was still young. This presents a puzzle for scientists. How could a galaxy with such a well-formed structure exist so early in the universe's history? According to current models, the chaotic conditions of the early universe should have made it impossible for galaxies like Sirius 2112 to form so quickly. The early universe was expected to be a place of intense turbulence, with gas and dust swirling around in violent movements. It was assumed that such turbulence would hinder the formation of stable, well-organized galaxies like those we see today. But the existence of Sirius 2112 suggests that the early universe may have been much more ordered than previously thought. One of the scientists who has been investigating the mystery of Sirius 2112 is Luca Constantine, an astrophysicist and postdoctoral researcher at the Astrobiology Center in Madrid, Spain. Constantine specializes in the formation and evolution of galaxies, particularly in understanding the physical mechanisms responsible for the structural composition of galaxies and their coevolution with central black holes. In a paper published on the discovery of Sirius 2112, Constantine and his team explored how a galaxy like this could have formed so early. They found that the galaxy's stellar mass and its barred structure fit perfectly with what we would expect from a much later stage of galaxy evolution, much later than the time when the universe was supposed to be only 15% developed. The fact that Sirius 2112 already had such a complex structure at such an early point in the universe's history suggests that the processes that govern galaxy formation might be much more efficient and faster than we previously imagined. Constantine's research raised a number of important questions about the evolution of galaxies in the early universe. According to previous models, galaxies were thought to be far too chaotic in their early stages to form such well-organized structures. Simulations of galaxy formation had predicted that barred spiral galaxies could only form after a galaxy's disk had settled into a relatively calm state, a process that would take billions of years. But the observations made by the JWST suggest that this process may be much faster than previously thought, or perhaps galaxies like Sirius 2112 were formed in a different way altogether. The discovery of a perfectly formed barred spiral galaxy in the early universe challenges our fundamental understanding of how galaxies evolve, and it may force scientists to reconsider many of the assumptions they have made about the timeline of cosmic development. The mystery deepens when we consider the broader implications of the JWST's observations. The JWST has the ability to observe distant galaxies, some of which are so far away that their light has taken billions of years to reach us. The telescope can see galaxies that formed just a few 100 million years after the Big Bang, giving us a glimpse into the early universe. However, so far, the telescope has not found the evidence of the early stars that were thought to have existed during this time. Instead, it has detected galaxies and black holes that appear to be much older than expected. This has led some scientists to question whether the universe is as young as we thought it was. The discovery of Sirius 2112 could be a clue that the universe's timeline is much older, or even that the universe had no beginning at all. In addition to the discovery of Sirius 2112, another intriguing discovery by the JWST is the observation of a galaxy named Macy's Galaxy. Named after the daughter of an astronomer at the University of Texas, Macy's Galaxy is one of the earliest galaxies ever observed, forming just 390 million years after the Big Bang. Macy's Galaxy, like Sirius 2112, is surprisingly well developed for its age, leading scientists to believe that there were already numerous advanced galaxies in the early universe, possibly with structures similar to our own Milky Way. These discoveries challenge the long-held view that galaxies in the early universe were disorganized and irregular. Instead, they suggest that the universe may have been more ordered and structured than previously imagined, with galaxies forming much more quickly and efficiently than we thought. These discoveries have sparked a new wave of research and speculation about the origins of the universe and the nature of galaxy formation. If galaxies like Sirius 2112 and Macy's Galaxy existed so early in the universe's history, it raises the question of how they could have formed so rapidly. Could there be processes at work in the early universe that we don't yet understand? Could the universe be much older than we thought? Or could it be that the Big Bang model of the universe's origins is incomplete or even incorrect? These are the questions that scientists are now grappling with, as they seek to understand the true history of the cosmos. The implications of these discoveries go beyond just galaxy formation. They challenge our understanding of the very nature of the universe itself. If galaxies like Sirius 2112 and Macy's Galaxy were able to form so quickly and so perfectly in the early universe, it suggests that the universe may have been much more organized and structured than we ever realized. This could imply that the universe has always been a much older, more stable place than we thought, or it could suggest that our models of the universe's development need to be completely revised. As researchers continue to study the data from the JWST, they will undoubtedly make more discoveries that will reshape our understanding of the universe's history. The discovery of Sirius 2112 and Macy's Galaxy is just the beginning of what promises to be an exciting and transformative era in astronomy. These discoveries force us to question everything we thought we knew about the cosmos and open up new possibilities for understanding the true origins and evolution of the universe. The mysteries of the early universe are far from solved, and the answers may be more surprising and awe-inspiring than we can imagine. For now, the questions remain. How could a galaxy like Sears 2112 exist so early in the universe? What does this mean for our understanding of galaxy formation and cosmic evolution? And what other secrets of the early universe does the JWST have yet to reveal? As scientists continue to analyze the data, we can only wait in anticipation for the answers that will help us unlock the greatest mysteries of the cosmos. The journey into the past, into the very beginning of the universe, has only just begun, and the truth we uncover may change everything we thought we knew about the universe and our place within it.